Okay, this is our second geometric proof video. I didn't want to put both proofs on the same video because it seemed like they were kind of going long. But you see how proofs look, the diagram with some givens, and then what we're asked to prove. And what we're asked to prove are the two triangles congruent. So we want to prove triangle BDC is congruent to triangle EAF. And all proofs have two columns with statements and reasons. And we begin by listing the givens. AB congruent to ED, segment AB congruent to segment ED, segment FE congruent to segment CB, segment FE perpendicular to segment AD, and also segment CB perpendicular to segment AD. And the reasons for these four statements are all going to be given. Okay, now let's begin. Let's mark what's been given and analyze this problem. We have AB congruent to ED. Here's AB, this little part here. That's congruent to ED, this part here. We now have FE right here, congruent to CB right there. And we have FE perpendicular to AD, FE and AD, so that's a right angle. And CB perpendicular to AD, that's a right angle. So if you think about how we prove things with side angle side, etc., we have almost side angle side. The problem is we don't have the whole side. We have just the AB. We need AE. We don't have DB. We have just DE. But the part that's missing from each, the overlapping part, is BE. If we can add BE to each part, we're good. And we can, in fact, add BE to each part. Okay? So let's first do the right angle part. And this is just like our other proof. Angle CBD and angle FEA are right angles. And what's the reason? Perpendicular lines form right angles. And we also know that those two angles are going to be congruent. Angle CBD is congruent to angle FEA. All right angles are congruent. Now, let's do the addition part. Oh, I'm running out of room on this proof. Let me see if I move this up higher. If I can get the whole paper in the video. Okay? So what we have to do is add this part BE to each segment. So what I'm first going to do is I'm going to say BE is congruent to itself. That is the reflexive property. The reflexive property says that any object is congruent to itself. Now, why did I do that? Write that down. Well, you see, the next thing I'm going to do is I'm going to say AB plus BE is going to be congruent to ED plus BE. And if you see in the diagram what I'm doing, I'm adding BE to this, AB, and BE to this BD. Because now what I end up getting is AE and BD. The reason for this is called the addition property. And the addition property in words is when equals are added to equals, the results are equal. So what do I get when I add AB and BE? Well, when I add AB and BE, I get AE. And when I add ED and BE, I get DB. The whole is equal to the sum of its parts. Now, we actually have this whole side here congruent to this one. So if you look at what we have, there's a side, and there's an angle. So we actually can finish this proof now and say that triangle BDC is congruent to triangle EAF, and the reason for this one is going to be side angle side. So you see, how is this proof similar from the one we just did? Well, we write our givens, we finish with what we're trying to prove, but as you can see, the in-between part and the steps are going to be different for each proof. Okay? Good luck, and don't be afraid to ask for help.